In this tutorial we will learn how to first run the server, second run the client, third define the waypoints for navigation, and fourth send the robot through navigation waypoints. For this tutorial we will need 3 Android mobile smartphones, 2 on the side of the robot and 1 on the side of the pilot. We will run the server in one of the smartphone devices. This device will connect the Raspberry Pi with the remote command server we saw in the previous video. Once we start the app, we press on the settings button. Here we can configure the addresses of all the involved elements. First, set up the IP and port of the command server address with the ones you previously set up. Second, set up the IP address of the RTMP streaming server you previously set up. Third, set up the local IP address of the Raspberry Pi so we can send from this device all the commands to the robot. Save the changes and exit. Back to the main menu, press Organize Connection. Next, press Create a new room. Now, type the name of your room and press Create Room. Select the number of simultaneous clients that will join the ride. For simplicity we will set only 2, that is the server and 1 client, the pilot. Since we are going to run the server, press on Play as 360 Streamer. Then on this screen you should specify the unique name of your RTMP stream. Let's use My Stream. Now press Confirm. Then it will establish the connection with our command server on one side and with the Raspberry Pi on the other. For now we are not going to work with Raspberry Pi, so you don't need to power it on. We don't need it to perform this first connection test. Once the connection has been established, you will get this screen. Here you can see the full RTMP path that you should specify in your 360 camera streaming app. In these 2 fields you can change the movement and the rotation amount of each command sent to the robot. In this list there will be the connected clients. In this area you will be able to see where the connected clients are looking at. You can close the connection with this button. The next time you start the app, the button Start to Stream will appear. By pressing this button, it will automatically create the session with the previous data you used. This shortcut is meant to ease the connection establishment process because you are going to usually perform the same connection multiple times. Now we run the app in another device and go to the settings. For the client we only need to specify the IP and port of the command server. Back to the main menu, press Organize Connection. Next, press Join a Room. Select on the list the room you created on the server side and press Join Room. Then press Play as Customer. You have 2 options. We will select Run it with gyroscope because you won't need a Google Cardboard headset. Now it's important that you set your nickname with the exact name you use for the RTMP stream. So we use what we previously used, My Stream. Press Confirm and the connection will be established. Here you will see a white screen, and if you move the smartphone eventually you will see the control panel. The reason why we are seeing a white background is that we have not started the video stream. You can start the video stream at any time, so let's do it right now. Connect the 360 camera and start streaming the 360 video. In a few seconds, that 360 video will be played in your client device. About the control panel, since the Raspberry is powered off, the commands you try to send right now have nowhere to go. On the next tutorial we will start the Python script on the Raspberry Pi that will listen for these commands. The screen navigation flow when running the app on Oculus Go and Oculus Quest is exactly the same. You can skip this section if you don't plan to use waypoint navigation. You will be able to send basic commands to your robot with what we have seen so far. The goal of the navigation is to select a path that the drone will follow automatically. That could be necessary if we want to check an area without having to worry about sending movement commands. So first we need to define the waypoints on the smartphone who is working on the server side with the robot. In the next video footage, you can see how I define the multiple waypoints and its connections to be able to navigate in my location. On real life, we will be placing these image markers. The OpenCV library which is working in the Raspberry will use these color markers to navigate between different waypoints. So once everything is set up on the server side, we can run the client and send the navigation commands by selecting the waypoints you want the robot to go. Once you confirm the path of waypoints, it will start the navigation and you will have a visual feedback of the current waypoint the drone is running to. Once it has finished the navigation, this button will appear again so you can send more navigation commands. It's important to stress out that if you use the basic movement commands during the waypoints navigation, that navigation will be cancelled in order for you to move with that basic commands. If you want to use again the navigation through waypoints after using the basic movement commands, it's important that you return the robot to the last valid waypoint position. In the first part of this tutorial, we have seen how to set up all the framework to perform the basic movements. In the second part, we have seen an optional functionality to navigate through a path of waypoints. On the next tutorial, we will run the Python script in the Raspberry connected to the robot.